Dear students, after studying this module, you shall be able to know about the total synthesis of complex organic molecules. Design the synthetic steps of the complex organic molecules. Understand the synthetic pathways of a complex organic molecules. Total synthesis of abscisic acid. Abscisic acid or ABA is a inhibitory rather a stimulatory hormone for plants. It is involved in the closure of stomata, bud and seed dormancy and is known to inhibit other hormonal actions. It helps the plant to survive under the adverse environmental conditions. Let us look into the heterosynthetic pathway for the given compound. The abscisic acid undergoes a carbon-carbon cleavage to form the two synthons with the functional group interconversion forming a keto group and a alkyne group. A diketo so formed can be obtained from isofuron. Synthesis. Isofuron is synthesized by the aldol condensation of acetone in presence of sodamide followed by dehydration as shown here in the given figure. The three acetone molecules in the presence of a base sodamide undergoes the condensation reactions leading to the final cyclized product with the loss of water molecules forming isofuron. The three molecules of acetone have been utilized in the following manner. In the step 1, the ketone group present in the isofuron is protected by reaction between isofuron and ethylene glycol under acidic conditions. After the protection, the mixture of two isomeric ketals is formed in the ratio of 70:30. These are the two double bonds isomers which are separated by fractional distillation. In the step 2, the ketal which is formed in the 70% yield on reaction with potassium permanganate under the basic condition forms a cis diol. Here on hydroxyl group is a secondary hydroxyl group while the other is a tertiary hydroxyl group. In the step 3, the secondary hydroxyl group in cis diol on further oxidation with potassium permanganate under basic conditions is oxidized to ketone. The tertiary alcohol in the step 4 is dehydrated using methane sulfonyl chloride under the basic conditions. Ketal is not cleaved under the basic conditions. That is the precaution which has already been taken care of. In the step 5, reaction of the compound 4 with Z 3-methyl 2-pentene 4-ionate in the presence of lithium diisopropyl amide also called as LDA at -78 degrees forms the corresponding compound number 6. The lithium salt so formed on hydrolysis forms the alcohol 7. This alcohol 7 is reduced to transalkene by using aqueous dimethylformamide solution of chromous sulfate. The ketal group in the transalkene is deprotected to the corresponding ketone using the ammonium ions. Sponification of the corresponding ketone followed by the acidification forms the target molecule abscisic acid. Total synthesis of ciprofloxacin. Ciprofloxacin is an antibiotic used to treat a number of bacterial infections. Some of them are bone and joint infections, diarrhea, respiratory tract infections, etc. It can be taken by mouth or used intravenously. Retrosynthetic analysis and the disconnection approach traces back the starting materials to be cyclopropylamine and diethyl malonate. Synthesis can be summarized in the number of steps as follows. In the step 1, 2,4 dichloro-5-fluorobenzoyl chloride condenses with diethyl malonate in presence of magnesium ethoxide in ether to form diethyl 2,4-dichloro-5-fluorobenzoyl malonate. In the step 2, the diethyl 2,4-dichloro-5-fluorobenzoyl malonate so formed is then partially hydrolyzed and decarboxylated by para-toluene sulfonic acid in water, forming ethyl 2,4-dichloro-5-fluorobenzoyl acetate. One of the group is hydrolyzed. Ethyl 2,4-dichloro-5-fluorobenzoyl acetate then condenses with triethyl orthoformate in refluxing acetic anhydride to form ethyl 2,2,4-dichloro-5-fluorobenzoyl 3-ethoxyacrylate. In the step 4, the given compound acrylate so formed on reaction with cyclopropylamine in ethanol gives ethyl 2,2,4-dichloro-5-fluorobenzoyl 3-cyclopropyl aminoacrylate. The aminoacrylate so formed on cyclization with sodium hydride in refluxing dioxane forms 7-chloro-1-cyclopropyl 6-fluoro-1,4-dihydro-4-oxoquinoline 3-carboxylic acid. In the subsequent step number 6, the oxoquinoline formed condenses with piperazine in hot dimethyl sulfoxide to form ciprofloxacin. Total synthesis of terphenedine. Terphenedine is an antihistamine drug used for treatment of allergic conditions. It was sold in the market by various brand names like Seldane, Triludan and Teldane. Retrosynthetic analysis. Again, the disconnection approach shows the given molecule can be traced back to benzophenone and chloromagnesium piperidine. The synthetic reactions show that the given compound can be prepared in the following various steps for the synthesis. In the step 1, Friedel-Crafts acylation of benzene with 4-hydroxybutyryl chloride in presence of aluminum chloride as a catalyst results in the formation of 4-hydroxy 1-phenyl butane 1-one. The ketone so formed on reaction with thionyl chloride results in the formation of 4-chloro-1-phenyl butane 1-one. The 4-chloro-1-phenyl butane 1-one is reduced to 4-chloro-1-phenyl butanol using sodium borohydride. In this step 4, 4-bromopiperidine on reaction with magnesium in dry ether forms piperidine magnesium bromide. The piperidine magnesium bromide on reaction with 4-chloro-1-phenyl butanol in the presence of pyridine as a base forms the compound number 1. The reaction of the structure 1 with tertiary butyl bromide in presence of aluminum chloride as a catalyst as in the Friedel-Crafts acylation forms the compound 2. Now, the reaction between 2 and benzophenone forms 3. The compound 3 so formed on hydrolysis forms terphenedine. Total synthesis of Captopril. Captopril is an angiotensin converting enzyme ACE inhibitor. This was discovered in 1977. This is used for the treatment of hypertension, some types of congestive heart failures and preservation of kidney function in diabetic nephropathy. It also shows mood elevation properties in some patients. Retrosynthetic pathway involves the cleavage of the carbon nitrogen bond of Captopril, leading to the formation of pyrrolidine 2-carboxylic acid, 3-mercapto 2-methyl propionic acid as the two precursors, which are then further traced back to 2-methyl acrylonitrile and 3-chloro 2-methyl propionitrile as the synthons. The synthetic approach involves, in the step 1, 2-methyl acrylonitrile is added onto HCl and forms 3-chloro 2-methyl propionitrile. The next step involves 3-chloro 2-methyl propionitrile on acidic hydrolysis forms 3-chloro 2-methyl propionic acid. The acid then reacts with hydrogen sulfide forming 3-mercapto 2-methyl propionic acid. The reaction of 3-mercapto acid with thionyl chloride results in the formation of a propionyl chloride. The condensation of the acid chloride, that is the 3-mercapto 2-methyl propionyl chloride so formed with pyrrolidine 2-carboxylic acid in presence of a base triethylamine results in the formation of Captopril. To summarize, abscisic acid or ABA is an inhibitory rather than stimulatory hormone for plants. Retrosynthetic pathway and corresponding synthetic pathways of abscisic acid is given. Ciprofloxacin is an antibiotic used to treat a number of bacterial infections. The retrosynthetic analysis shows that the molecule ciprofloxacin can be synthesized from diethyl malonate. The retrosynthetic pathway and total synthesis of ciprofloxacin are explained here in the given schemes. Terphenedine is an antihistamine drug used for the treatment of allergic conditions. The retrosynthetic pathway and total synthesis of terphenedine are explained with the scheme. Captopril is angiotensin converting enzyme inhibitor and was discovered in 1977. The retrosynthetic pathway shows that Captopril can be synthesized from 2-methyl acrylonitrile.